So this is our last problem session for the semester. Final exam is on Wednesday morning, I think. Let me just remind you that final exam is 2 days from today. The 15th, during our regular class time, starts at 11, ends at 1. And what I'm going to do now is review the practice exam. Any questions before I start? So problem number 1, we have y is square root of 5 plus x to the 5th over 5 minus 5 log x. And we want to find the derivative. The derivative of a constant is 0. The derivative of x to the 5th is 5x to the 4th over 5 minus 5. Derivative of log x is 1 over x. So we get x to the 4th minus 5 over x. Any questions? P of y is a rational function. So p prime of y, you square the denominator, the derivative of the numerator times the denominator, minus the numerator times the derivative of the denominator. The y's cancel. 15 minus 14 is 1. That's the answer. Questions about that? Problem 3, we have the curve given by y equals 1 plus 2e to the x, and we want to find the tangent line at x equals 0. So the derivative of 1 plus 2e to the x is 2e to the x. And if you evaluate that at x equals 0, you just get 2. So this is what the curve of 1 plus 2e to the x looks like. You want to find the tangent line at x equals 0. When x is 0, y is 2. So the equation of the tangent line is y equals 2 times x plus 2. This is the line with slope 2, which goes to the point 0, 2. Questions? Okay. Problem 4, we have a curve given by the equation 5x squared plus 3y squared plus xy equals 15. And we want to find the tangent line at point minus 1, 2. And you can check if you let x equal minus 1 and y equal 2, this really lies on this curve at 5 times minus 1 squared. plus 3 times 2 squared plus minus 1 times 2 is 5 plus 12 minus 2 is 15. This is just a check that this point really does lie on the curve. What's the slope of the tangent line to the curve at this point? We have to use implicit differentiation. So when we differentiate with respect to x, we get 5 times the derivative of x squared, which is 5 times 2x, plus 3 times 2y dy dx, plus 1 times y plus x times dy dx equals the derivative of 15, which is 0. So this is 10x plus y plus x plus 6y times dy dx. 10x plus y, 6y plus x. So dy dx is equal to minus 10x plus y over x plus 6y. And when you evaluate that at the point x equal minus 1 and y equals 2, you get minus 10 plus 2 over minus 1 plus 6 times 2. So that's minus 8 over 12 minus 1. So this is the slope of the tangent line at this point. So the equation of the tangent line is y equals 8 over 11 x minus 1 plus 2. So that's 8 over 11x plus 8 over 11 plus 2, which is 22 over 11 plus 30 over 11. So this is the equation of the tangent line. Questions? All right. Problem 5, we have w is the square root of 1 plus z times e to the z. So dw dz, we have to use the chain rule. Is this expression to the power 1/2. So that's 1/2, 1 plus z e to the z to the minus 1/2 times the derivative of 1 plus z e to the z. Derivative of 1 is 0. Derivative of z e to the z is 1 times e to the z plus z times e to the z. So we get is 1 plus z times e to the z over 2 over the square root of 1 plus z e to the z. Oops, there we are. This is the chain rule. This function is 1 plus z e to the z to the 1/2. So when you differentiate, you get 1/2, this to the minus 1/2, times the derivative of 1 plus z e to the z, which is this. Right. Questions? 1, 2, 3, 4, 5. So next is number 6. The limit theta goes to 0 of 3 sines a sine of 4 theta over 5 theta. So it's nice to have sine 4 theta over 4 theta. So let me write it like this. I have sine of 4 theta, and I have a 5 times theta in the denominator. If I want to have a 4 here, I can multiply the denominator by 4 and the numerator by 4. So this is 12 over 5. The limit sine 4 theta over 4 theta. Theta goes to 0. And this limit we know is 1. So the answer is 12/5. Okay. Questions? Problem 7 is the limit as x goes to 1 of x squared minus 4x plus 3 over x squared minus 1. Now, you can't just substitute x equal 1 in because you get 0 over 0, which is undefined. But you observe that the numerator and the denominator both factor. This is equal to x minus 1 times x minus 3. And this is x minus 1 times x plus 1. So these terms cancel. So this is the limit as x goes to 1 of x minus 3 over x plus 1, which is 1 minus 3 is minus 2 over 2. So the limit is minus 1. Problem 8, another limit as x goes to infinity of 6x squared plus 100 over 7x squared minus 100. Again, when you have a rational function where the polynomial in the numerator has the same degree as the polynomial in the denominator, the limit is just the ratio of their leading coefficients, which if you like, you could also see as follows. This is the limit as x goes to infinity. If I divide by x squared, the numerator and denominator, I get 6 plus 100 over x squared over 7 minus 100 over x squared. And as x goes to infinity, these terms go to 0. And we're left with 6/7. Right. Problem 9, we have a function q of x defined as follows. It's x squared plus k if x is less than or equal to 0, and cosine x if x is greater than 0. So the cosine looks like that. And x squared plus k is a parabola, which is equal to k when x is equal to 0. And you get a continuous function exactly when these two things agree. That means this function is continuous for all k if k is equal to 1. Then you have the parabola, looks like that. You have the parabola and then the cosine. Questions? No. Okay. Problem 10 is to compute the derivative of 1 over x using the definition. So the derivative of 1 over x is the limit as delta x goes to 0 of 1 over x plus delta x minus 1 over x divided by delta x. Now this numerator, if I put it over a common denominator of x times x plus delta x, I get x minus x plus delta x, which is minus delta x over x times x plus delta x. So this is the limit, delta x goes to 0, of this divided by delta x, which cancels this delta x, of minus 1 over x plus delta x times x. When delta x goes to 0, I get minus 1 over x squared. Problem 11, we have a cube whose side is S. The volume of a cube is S cubed. And we're told that the volume is increasing at a constant rate of 120 cubic inches per second. And we want to find how fast the side is increasing when S is equal to 8. So if V is S cubed, dV dt is 3S squared ds dt. And dV dt, we're told, is constant, 120 cubic inches per second. And when S is equal to 8, this is 3 times 64. 3 times 64 is 192. This is 192 ds dt, which means ds dt is 120 over 92, which if we reduce this to lowest term, let's see, you can divide 4 into each thing, 30 over 48. And I can divide 6 into these, 5 over 8. So 5/8 inches per second. So V is S cubed, dV dt is 3S squared ds dt. The volume is 120. When S is 8, this is 3 times 64, or 192. So ds dt is 120 over 192. You get 5/8. Questions? Number 12, we have y equals x cubed minus 6x squared. This is a pretty cubic curve. Cubic curve, actually you can see this is the same as x squared times x minus 6. So this is 0 at 0 and 0 at 6. And cubic curve generally goes up, comes down, goes up again. And we want to find where it's concave up and down and where it has inflection points. So we need the second derivative. dy dx is 3x squared minus 12x. The second derivative is 6x minus 2. Sorry, 6x minus 12 is 6 times x minus 2. So the second derivative is greater than 0 when x is greater than 2. So here is concave up. The second derivative is less than 0 when x is less than 2. So there is concave down. And the second derivative is 0 at x equal 2. And that's where we have the inflection point. So when x is 2, y is equal to 8 minus 24, right? 8 minus 6 times 24 minus 24 is minus 16. So here at 2 minus 16, that's the inflection point. In problem 13, we have a 4th degree polynomial, x to the 4th minus 4x squared plus 2. 4th degree polynomial usually looks like this. So typically you would expect to find 2 relative minima and 1 relative max. What are the relative extrema? Well, f prime of x is 4x cubed minus 8x, which is 4x times x squared minus 2. This equals 0 at x equals 0 and x equal plus or minus square root of 2. The second derivative is 12x squared minus 8. So when x is equal to 0, you get minus 8, negative, so you have a relative maximum. When x is plus or minus the square root of 2, this is 12 times 2. 24 minus 8 is 16. So here we have relative minima. So these are the relative extrema. Take the first derivative. It's 0 at 0 and plus or minus 2. Evaluate the second derivative at the critical numbers. 1 is negative. That's your relative max. And 2 of them are negative. So these are your relative mins, minus root 2 plus root 2. Okay. That's 13. Problem 14. We have the function f of x equals 4x cubed minus 3x squared, and we want to find the absolute max and min on the interval from -1 to 1. So the first derivative gives us the relative maxima and minima, 12x squared minus 6x. So this is 6x times 2x minus 1. So x equals 0 and a half are where you have the relative maxima and minima. So we have to calculate the value of the function at 0 and a half, and at the endpoints 1 and minus 1. And at those points, f of 0 is 0, f of 1 is 1, f of minus 1 is minus 7, and f of a half, this is a half, 4 times an eighth, it's a half, minus 3/4. A half minus 3/4 is minus a fourth. So this is the absolute max on this interval, and this is the absolute minimum. 4x cubed minus 3x squared, you get 12x squared minus 6x. That's 6x times 2x minus 1, so x equals 0 and a half are the critical numbers. At 0 and a half, this is 0. And minus a fourth. But at the endpoints, it takes on very big values, minus 7 and 1. Problem 15, a particle is moving along the x-axis with an acceleration at time t equal to 6t plus 2. And the initial position at time 0 is 3, and the initial velocity at time 0 is 4. And we want to find s of t. So if the acceleration is 6t plus 2, the acceleration is the derivative of the velocity. So the velocity is the antiderivative of the acceleration. That means you take the integral, you get 3t squared plus 2t plus a constant. And the velocity at time 0 is c is 4. So the velocity is 3t squared plus 2t plus 4. And velocity is the derivative of the position. So the derivative, so the position is the antiderivative of the velocity. S of t is the integral, 3t squared plus 2t plus 4. So when we integrate, we get t cubed plus t squared plus 4t plus a constant. And S of 0 is 3. So when you plug in 0, you get c equals 3. So S of t is t cubed plus t squared plus 4t plus 3. Position at time 0 is 3. Differentiate, you get 3t squared plus 2t plus 4. The velocity at time 0 is 4. Differentiate for the acceleration, 6t plus 2. So everything works out perfectly. Questions? Okay. Problem 16 is to find the optimal size for a poster. A poster is to have an area of 100 square inches with a 1-inch margin on the right and left sides and a 2-inch margin on the top and bottom. So our poster is going to look like this. The margin at the top and the bottom is 2 inches. The margin on the right and left is 1 inch. And the whole poster has an area of 100 square inches. But this is the printed part of the poster. So find the dimensions that maximize the printed area. So if we were to, for example, call this X and this Y, the total width is X plus 2. The total height is Y plus 4. And that total area is 100 square inches. And we want to maximize X times Y. Of course, what this says is that Y plus 4 is 100 over X plus 2. So Y is 100 over X plus 2 minus 4. So as a function of X, once you have X, that determines Y. As a function of X, the area, which is X times Y, is X times 100 over X plus 2 minus 4X, or 100X over X plus 2 minus 4X squared. So A prime of X, the derivative, is X plus 2 squared, derivative of the numerator, times the denominator, minus the numerator, times the derivative of the denominator, which is just 1, minus 8X. This is 100X minus 100X. So this is 200 over X plus 2 squared minus 8X. And we want that equal to 0. So that's equal to 0 when 8X equals 200 over X plus 2 squared, which means X times X plus 2 squared equals 200 over 8. which is 25. Let me double check everything because this looks more complicated than I would like it to be. This was number 16. It just looks like this is too hard a calculation. And I'm not sure whether the people who put together this practice final did this correctly. So the total area of the poster is 100 square inches. So if x plus 2 and y plus 4 are the dimensions, that's 102. And what you want to maximize is the area of the printed part, which is x times y. So, but in terms, if you write y in terms of x, because the total area is 100, y plus 4 is 100 over x plus 2. So y is 100 over x plus 2 minus 4. You multiply, here's my mistake, it's good. 100 over x plus 2 minus, not minus 4x, minus 4. I don't know why I wrote that. So this is 100x over x plus 2 minus 4x. So when you differentiate, this is just minus 4. Perfect. So this means that 200 over x plus 2 squared equals 4. So x plus 2 squared is equal to 25. So x plus 2 is 5. So x is equal to 3. And when x is equal to 3, y is 100 over x plus 2, 5 minus 4. 100 over 5 is 20 minus 4 is 16. So you maximize the area of the printed poster when x is 3 and y is 5. So the dimensions of the whole poster are 5 by 20. And the inside poster is 3 by 16. Okay, good. That was number 16. So number 17, let's take a look. Write a 3-term Riemann sum for the integral from 0 to 1 of the square root of 1 plus x squared dx. So if you graph y equals the square root of 1 plus x squared, when x is 0, it's 1. And when x is 1, it's the square root of 2. So for a 3-term Riemann sum, you could divide this interval up into 3 pieces. One-third, 2/3. And you could just take these 3 rectangles. So the Riemann sum would be the value of the function at 1/3. Suppose we let f of x be the square root of 1 plus x squared. So you could take f of 1/3 times 1/3, f of 2/3 times 1/3, f of 1 times 1/3. So f of 1/3, this is 1 plus 1/9. One plus 1/9 is 10/9. F of 2/3, this is 4/9. This is square root of 13 over 9 times a third. And when if this is 1, this is the square root of 2 times a third, for example. There are many different ways to do it. Any questions? To find the area under the curve of 5 minus 2x squared from 0 to 1, you take the definite integral. So the antiderivative of 5 minus 2x squared is 5x minus 2/3 x cubed. Because you differentiate that and you get 5 minus 2x. Evaluated from 0 to 1 is 5 minus 2/3. It's 13/3. Problem 19. If you have f of x is the integral from 0 to x of 1 over the square root of 1 plus t cubed dt. By the second version of the fundamental theorem of calculus, when you differentiate the integral, you get the integrand, 1 over the square root of 1 plus x third. If you know the fundamental theorem of calculus, you write down the answer. If you don't know it, it's impossible. And if you want to integrate x sine of x squared dx, this is a substitution. Let's say this is sine of x squared. I'll write 2x times a half, because a half times 2 is 1 dx. And now if I substitute u equal x squared, this is 1/2 the integral of sine of u du, which is minus a half cosine u plus a constant, which is minus a half times the cosine of x squared plus a constant. Okay, any questions about that? This is the whole practice exam, and the departmental final is extremely similar to this. It'll be the same number of questions, the same type of questions. There'll be different questions, but they're exactly the same types. Right. Any questions? Again, I remind you, they're office hours today and tomorrow, if you have some last minute questions. If not, then I guess we are done. I will post this on Blackboard. And good luck on this and all your other finals. Right. Bye all.